Hello, podcast listeners. I'm going to record an episode of the 365 Days of Astronomy podcast now. It'll be for Thursday. This is the 365 Days of Astronomy podcast. Today we bring you a new episode in our Space Scoop series. This show is produced in collaboration with Universe Awareness, a program that strives to inspire every child with our wonderful cosmos. Today's story is A Puzzling Geometry Conundrum. Imagine standing on the planet Tatooine from Star Wars and seeing two suns in the sky. Whoa! When we study geometry in school, we're learning about the shapes and dimensions of different objects, sines, cosines, and tangents, that sort of stuff. Great stuff. I love geometry. Planets and stars also have their own geometry, but sometimes the answer doesn't add up. By studying the geometry of the birthplaces of planets, astronomers hope to discover how planets form in different environments. In the earliest parts of its parts. See, I edit this stuff out. In the earliest part of its life, case in point. In the earliest part of its life, a star is called a protostar. The star is simply a ball of cold gas and dust that's collapsing under hair in my mouth. Okay. The star is simply a ball of cold gas and dust that's collapsing under the force of its own gravity. It doesn't even have It doesn't even have nuclear fusion in its core, so it really isn't even a star yet. But just wait. With time, the cloud collapses and it begins to spin, forming a flattened disk around the protostar. This is so cool. It's called the conservation of angular momentum. Think of an ice skater pulling in her arms and spinning faster and faster. At the start, there is some small, insignificant rotation to the cloud. This rotation is amplified as the outer parts move inward. Material from this disk feeds the star and makes it grow. As it continues to collapse, the protostar squashes into an ever tighter, hotter ball. Our proverbial ice skater spins faster and faster. Eventually, the leftover had a good run there. Eventually, the leftover material in this disk forms rings. In these rings of had a good run there. In these rings of dust and gas called protoplanetary disks is where planets are born. But these rings are not found just around single stars. When two stars are born together and orbit around each other, they are what we call a binary star system. Most stars are part of binary systems. We also believe that about half of all planets are in binary systems. It's like a special cosmic geometry problem that forces us to look at all of the different pieces of the puzzle. Astronomers using ALMA, the Atacama Large Millimeter Submillimeter Array radio telescope in Chile, are studying these protoplanetary disks around protostars in binary systems. To their surprise, the geometry is not very clean and simple. The binary stars and their disks of material do not always line up like you might expect them to. They found that if the two protostars in a binary system take a longer time to orbit each other another good run. We'll try to get farther in it this time. They found that if the two protostars in a binary system take a longer time to orbit each other They found that if the two protostars in a binary system take a longer time to orbit each other and are in a large, slow orbit where the two stars are relatively far apart, then it appears more likely that their protoplanetary disk will not be aligned to the parent stars. The shorter the orbital period of the binary star, the more likely it is to have a disk in line with its orbit. How short? Well, okay. Well, where the central stars have orbital periods less than 40 days, the orbital planes are quite closely aligned, within 3 degrees. When the binaries have periods longer than 40 days, they typically have misaligned disks. In one case, the disk was fully perpendicular with a polar orbit. This appears to be a stable system in the computer models. So you might well ask, well, why does this happen? Short orbital period binary stars, with their closeness to each other, exert tidal friction on each other and gradually change their orbits from ellipses to circles. Then, over millions of years, this gravitationally tugs the protoplanetary disk into alignment with the orbit of the two stars. And the binary stars that have longer orbits, those over 40 days, they have disks that are arranged in all possible inclinations from coplanar to polar. Based on this finding, the astronomers believed that so-called misaligned planets around binary stars should also be out there for us to find. Let me stress planets more. Based on this finding, the astronomers believed that so-called misaligned planets around binary stars should also be out there for us to find. Now, it's not likely that there are a huge number of them, but they'll be out there, and you can be sure that astronomers are looking for them.
Tatooine, here we come. Find you we will.
Hey, here's a cool fact. As a protostar grows and evolves into a star, it experiences a huge increase in temperature. Eventually, the heat and pressure is enough to start nuclear fusion, and voila, a star is born. This can take it from a freezing -250 degrees Celsius to anywhere up to 40,000 degrees on its surface when it becomes a fully fledged star. If our spinning ice skater does this, she'll melt right through the ice. Thank you for listening to the 365 Days of Astronomy podcast. Oh, and wash your hands, everybody. Please. Thank you so much.